Assalamu alaikum students. Today we are going to solve the MCQs of electromagnetic induction. First MCQ is induced EMF or current is produced in a coil depends on. So induced EMF always depend upon the rate of change of magnetic flux. Like EMF is equal to rate of change of magnetic flux, okay? And this flux also depend upon the magnetic field area and the angle, okay? So induced EMF depend upon the rate of change of magnetic flux. Look at here, EMF is equal to rate of change of magnetic flux. This magnetic flux is equal to magnetic field multiply area and cos theta, okay? Now change in magnetic flux is also depend upon change in magnetic field, change in area, or change in the angle, okay? So we can say that when we change the magnetic field with time, okay, so it also produces the EMF, okay? When we change one of these element with time, okay, so it produces EMF. Now look at here, option C is correct. We have to mention the rate of change, okay? So option C is correct here. According to Lenz's law, the induced EMF in the coil is opposite to the cause producing it. Option D is correct here. Now look at here, EMF is equal to minus rate of change of magnetic flux, where N is the number of turns, okay? So this negative sign shows that the EMF always opposite to the cause producing it, okay? So option D is correct. Lenz's law is a particular form of the law of conservation of energy. Option C is correct. Let's see how Lenz's law is the law of conservation of energy. Now look at here, this is a magnet, okay, and this one is the coil. Now when we increase the magnetic field, okay, like increase means that when we move the magnet in that direction, it means that we are increasing its effect, okay? So in that case, what will happen? This coil will oppose the effect, the cause producing it. The EMF or the current in this coil will oppose the effect of this, okay? Now in order to keep the EMF constant, so this will oppose this increase, okay, and in turn the north pole will be produced in it, okay? So according to right hand thumb rule, the direction of current will be anti-clockwise, okay? Now look at here, when the north pole is on this one side, okay, and it is increasing or we moving in that direction, okay, towards the coil, what will happen? North pole will be appeared on this face and south pole will be appeared on the back side, okay? So look at here, the direction of magnetic field will be like this, okay, on this side. The induced magnetic field will be on this side. And look at here, in this case the direction of magnetic field is on here, okay, towards the coil. Now both are opposing each other. Look, this induced magnetic field is opposing this one, okay? So it means that this coil prevents the further increase in the EMF and the magnetic field of this magnet, okay? Now look at here, in case when we are decreasing the effect of this magnet, okay? Look at here, decrease means that when we are moving away from the coil. Now what will happen? When this magnet is moving away from the coil, in that case the south pole will appear, okay? In order to keep the EMF constant, what will happen? South pole will be appeared here, and on the other face the north pole will be appear. So in this case the direction of magnetic field is this one, okay? And according to right hand thumb rule, the direction of magnetic field current, the direction of current will be clockwise, okay? Direction of current in this case will be clockwise. Now look at here, when the effect is decreasing, what will happen? Or we can say when the magnet is moving away from the coil, look, the direction of induced magnetic field will be in the direction of the magnetic field of the magnet. Look, the directions are same, okay? So the conclusion is that when the magnetic field is increasing, then the induced magnetic field will be opposite to the direction of this one, okay? And when the magnetic field is decreasing, look, this arrow means that we are moving away from the coil and its effect is decreasing, okay? Now when the magnetic field is decreasing, what will happen? The induced magnetic field will have the same direction as that of the cause, okay, as that of this one magnetic field. So when we move the magnet towards and away at a time, what will happen? The energy in this coil will remain same. Okay, look, in this case it is opposing the increase, and in this case this one is opposing the decrease. Okay, so energy will remain same. So we can say that Lenz's law is the law of conservation of energy. Look at here, option C is correct. Okay, when the current in a coil decreases, then the induced current in the coil, option A is correct here, along the direction of the current. Now look at here, the current here is increasing. Okay, so in this case when the current is increasing, what will happen? This is primary coil. Okay, and in secondary coil the current will tend to decrease the effect of the magnetic field of this one. Okay, look, the current here is increasing. Let's suppose its direction is clockwise. Okay, let's suppose its direction is clockwise. The current here is increasing. Okay, it means that the magnetic flux will also increasing. Okay, or magnetic field will be increasing, magnetic field. So look, its direction is like this. Okay, magnetic field has this one direction. Now it's increasing. What will happen? In this coil the magnetic field will tend to decrease its effect. Okay, the current or the EMF in this coil will produce in that direction in order to oppose the current in this primary coil. Okay, now let's suppose the current here is clockwise. Okay, now, and we know that the current is increasing, so in this coil the current, the induced current or the induced EMF induced current will be anti-clockwise. Okay, in this coil the induced current will be anti-clockwise, and look, the direction will be also opposite. Okay, the direction of magnetic field will be opposite to the direction of this one magnetic field. Okay, because this one will try to decrease the effect of this. Okay, so we says that the induced EMF oppose the cause producing it. Okay, or the induced current oppose the cause that producing it. Now look at here, when the magnetic field is decreasing, then what will happen? The EMF or the current in this coil will produce in that direction that increases the effect of this one. Okay, now look at here, when the magnetic field is decreasing, so in this case the induced magnetic field will increase. Okay, the current will also increase, and look, the direction of both will be same. Okay, the direction of current in clockwise, let's suppose here the direction of current is clockwise, then the direction of induced current will also be clockwise. So the conclusion is that in case of increase in the current or magnetic field, the direction of current and magnetic field will be opposite to the direction of this one. Okay, in case of decrease in the current and the magnetic field, the direction of current and magnetic field, or we can say EMF, will be the same as this one. Okay, the direction of both will be same. Now come to the MCQ. When the current in a coil decreases, look, the current is decreases, then the induced current in the coil is along the direction of the current. Option A is correct here. Fifth, a current in the coil flowing in clockwise direction decreases gradually with the passage of time. The direction of induced current. Now look at here, the current is decreasing. Okay, when the current is decreasing, what will happen? The induced current will have the same direction as this one. Okay, so option A is correct here. Look, the induced current will have same direction as the current in the primary coil. Look at here, when the current is increasing, the induced current and the magnetic field will have opposite direction. Okay, well, it will have opposite direction in order to decrease its effect. Okay, in order to decrease its effect. Now when the current is decreasing, the induced current and the induced magnetic field will have the same direction to this one. Okay, in order to increase its effect. Okay, in order to increase its effect. So here option A is correct. A conductor of length 100 cm is dragged at right angle to a uniform magnetic field of 0.5 Tesla with a speed of 500 cm per second. The motional EMF induced is. Now look at here, motional EMF is BLV. Okay, this one is the formula for motional EMF, where B is 0.5 Tesla and length is 100 cm, which is equal to 1 meter, and speed is 500 cm per second, which is equal to 5 meter per second. So on multiplying these three, you will get 2.5 volt. So look at here, option C is correct, 2.5 volt. The ratio of induced EMF in the secondary coil to the rate of change of current in the primary coil is called. We know that EMF is equal to EMF in secondary coil is equal to motional EMF and the rate of change of current in primary coil. Now look at here. When we bring this one in multiplication, okay, in division here, so motional EMF will be, look, EMF in secondary coil to the rate of change of current in primary coil. So here option B is correct. A current in a primary coil is changed from 5 ampere to 1 ampere in 6 seconds. An induced EMF of 10 volt is produced in the nearby placed secondary coil. The coefficient of mutual induction is. Now we know that motional EMF is motional induction. Motional induction is equal to EMF in secondary coil multiplied by rate of change of current in primary coil. So when we bring this time here, so it will be E multiplied by change in time divided by change in current. Okay, so we know that EMF is 10, okay, and look at here, time is 6, this one here negative. Okay, now the change in current, so final minus initial, it will give minus 4. Okay, now look at here, 2 2s are 4, 2 3s are 6, okay, and 2 1s are 2, and 2 5s are 10, so 5 3s are 15. Okay, and this minus will cancel this one, so mutual EMF is equal to 15 Henry. So option A is correct here. 1 Henry is equal to, we know that Henry is the unit of mutual induction as well as the self-induction. Okay, now let's take mutual induction. Okay, M is equal to EMF divided by time rate of change of current. Okay, this one is the mutual induction. Now bring this T here, so you will get M is equal to E multiplied by time or current. Look, we have to find the unit of Henry. Okay, so this is current. Okay, EMF is volt, T is second, and look, current is ampere, so volt second divided by ampere. Option A is correct here. The time rate of change of magnetic flux has the same dimension as that of, here we know that this one is the time rate of change of flux, okay, magnetic flux, and this is EMF, and we know that EMF, the unit has, EMF has the same unit as volt, okay, or we can say potential difference, V. So option D is correct here. EMF has the unit of volt and potential difference has also the unit of volt. The rate of change of current in a coil take place at 10 ampere per second. If the coefficient of self-inductance of a coil is 100 millihenry, then the EMF induced in the coil, we know that EMF is equal to negative L and change in current divided by change in time. Okay, so the time rate of change of current is 10 ampere per second, so we will take this as 10, and self-inductance is 100 millihenry, so it is 0.1 Henry multiplied by 10, so minus 1 volt. Now this negative sign shows the direction, okay, that the direction of both will be opposite, so we will just ignore this negative sign. Okay, and here the answer will be 1 volt. Okay, the magnitude of EMF will be 1 volt. Here this negative sign shows the direction, so you have to ignore this one. Okay, 12. The self-inductance of a solenoid is, let's see the option. Here A, B, C and D option is given. Let's prove this one. Now look at here, we know that self-inductance is equal to EMF multiplied by time divided by change in current. Okay, and we can also write this one as N magnetic flux divided by current. Look, magnetic mutual inductance has two formulas, one is this one and the other is this one. Okay, now this magnetic flux, we know that B dot A, okay, magnetic flux is equal to B dot A. Now look at here, we know that this B is also equal to, according to Ampere's law, look, mu, N and current. Okay, permeability of free space, this mu represents permeability of free space. Now cancel out this current. Okay, so remaining will be N, and here we also know that this smaller n is equal to N divided by L, number of turns per unit length. Okay, so put this capital N divided by L here, N divided by L, so you will get N square mu permeability of free space area divided by length. Okay, so look at here, this one is the answer. Okay, This one is the self-inductance of a solenoid, okay? Option A is correct here. Inductor stores the magnetic energy. Option B is correct here. Like we know that when we introduce the current in a inductor, what will happen? The magnetic field produces, and this magnetic field also induce the current in other coil. So in this case, the inductor stores the magnetic energy, okay? An inductor have self-inductance of 100 millihenry. If a current of 10 ampere flows in it, then the energy stored in it is, look, the energy stored in conductor is 1 over 2 Li square, okay, where L is the 100 millihenry, which is equal to 0.1, okay, 0.1, and the current is 10 ampere, so 10 tens are 100, so you will get 5 joule, okay. Option A is correct here. 1 Henry multiply ampere square is equal to, now look at here, we know that 1 Henry is equal to voltage multiplied by second divided by ampere, okay, and ampere square is this one, okay, so this one will cancel, so voltage multiplied by second multiplied by ampere, so this ampere into second is equal to coulomb, and we can say that voltage is equal to joule per coulomb, okay, voltage is joule per coulomb and ampere into second is also coulomb, so these two will cancel each other, and here option B will come, okay, 1 joule. What is the inductance of the arrangement as shown in figure? Now look at here, the arrangement is parallel, okay, these two inductors are in parallel combination, so the formula is L equivalent is equal to L1 multiply L2 divided by L1 plus L2, okay, this one is the formula. Now look at here, L equivalent is equal to, so L1 multiply L2 means 30 multiplied by 60, so it will give 1800. L1 plus L2, 30 plus 60, it will give 90, okay, so it will give 9 ones are 9, 9 2s are 18 and 20, so 20 millihenry is the equivalent inductor, okay, so option B is correct here. 17. The EMF induced in the AC generator is E. If the angular speed of the coil is tripled, then the EMF induced is. So the formula for EMF in AC generator is NAWB. Okay. Now, when we triple the angular speed, so the EMF will also triple. Here option C is correct. The coil in AC generator rotates with angular speed of 10 radian per second. Its frequency in SI unit. Here we know that in case of angular speed 2 pi f, okay. Now we have to find the frequency, okay. So it will f omega divided by 2 pi. So angular speed is 10. 10 divided by 2 will give 5. So the answer will be 5 divided by pi. 5 divided by pi, okay. Option B is correct here. The sinusoidal current flowing in AC generating coil is, now we know that I instantaneous is equal to I maximum current sine theta, okay, and this is I sine omega t, so it will give I naught, okay, sine omega is equal to 2 pi f, and this one will be t. Now look at here, option B, omega I naught sine 2 pi ft, option B is correct here, okay. The working principle of transformer is based on mutual induction. We know that in transformer there is primary and secondary coil, okay. The current or the EMF is generated in the primary coil, the current or the EMF is provided to the primary coil, okay. It is provided, AC current is provided to the coil, and in turn the current or the EMF is produced because of the mutual induction in the secondary coil, okay. The current is produced in the secondary coil because of the mutual induction, so option B is correct here. Transformer steps up or step down the AC only, okay. Transformer work on the AC only. means alternating current. Okay, transformer increase or decrease the alternating current or the voltage. Okay, so here in this option the AC alternating current is the correct one. A transformer has 100 turns in the primary coil and 200 turns in the secondary coil. If 200 volt EMF is induced in the secondary coil, then the input EMF. So the required is the input EMF, which means the voltage in the primary coil. We know that Vs divided by Vp, voltage in primary, is equal to Ns divided by Np. Okay, now the required is what? Vp, voltage in the primary. So what you have to do, bring this Np here. Okay, bring this one here and exchange the places of these two. Okay, like Np multiply Vs and bring this Ns here and Vp there. Okay, Ns is equal to Vp. Okay, now the required is Vp. Now look at here, Np, number of turns in the primary coil, is 100 and Vs is 200. Okay, and divided by 200, so it will give 100 volt. Okay, look at here, 100 multiplied 200, so these will cancel each other and the voltage in the primary coil will be 100 volt. So option D is correct here. Okay, the ratio of EMF across the primary coil to the EMF across the secondary coil is, look, EMF in the primary coil to the EMF in the secondary coil. Okay, we can also call it voltage. Okay, now look at here, we know that for current the formula will be Is divided by Ip. Okay, look, the relation between the Vp and Ip is inverse. Okay, and the relation between Vs and Is is inverse. Now if we write this formula in case of number of turns, it will be Vp divided by Vs is equal to Np divided by Ns. It means that the relation between the voltage and the number of turns is direct. Okay, it has direct relation, while this one has inverse relation. Now look at the option A. Here this one is incorrect. Okay, N is Np, and here the required is, the correct is these. Okay, now look at the B option, Is divided by Ip, Is divided by Ip, so option B is correct here. If the speed of rotation of AC generator is made 4 times of its initial value, the percent increase in induced EMF is, now look at here, EMF is equal to NAWB. Okay, where N is the number of turns, A is the area, and W is the omega is the angular speed, and B is the magnetic field. Okay, now keeping these 3 things constant. Okay, when we increase only the omega, angular speed, 4 times, look, when we keep these constant, so it will give, is directly proportional to the omega. Okay, when we keep these 3 things constant, then EMF will be directly proportional to omega, and when we increase the omega 4 times, then what will be the percent change? Now look at here, simply take this 4 and subtract 1 from it. Okay, and multiply it with 100%, so you will get the percent change is 300%. Okay, the percent change will be 300, and when we increase the angular speed 4 times, so in this case this EMF will also increase 4 times. Okay, so instead of doing the whole process for finding the percent change, you simply do this method. Okay, take this 4, subtract 1 from it and multiply it with 100, you will get 300%. Now look at here, option C is correct. Okay, 25. The transformer on a power pole steps down the voltage from 10,800 volt to 120 volt. Now there is a transformer that step downs the voltage from this to this. Okay, the voltage in the primary coil is this one, and the voltage in the secondary coil is this one. Okay, this is Vp and this one is Vs. Now if the secondary coil contains 3600 turns, now Ns is 360. Okay, sorry, 360 is there. How many turns are on the primary coil? Now we have to find the Np. The Np is unknown. Okay, now look at the formula, Vs divided by Vp is equal to Ns divided by Np. Okay, now in order to find the Np, bring this Vs, exchange their places. Okay, like Np is here and bring this Vs here, and bring the Vp here in multiplication. Okay, look, it will be like this. NS divided by VS multiplied by VP. Okay, now the 360 multiplied by 1000, 10,800 divided by 120. Now when 123s are 360. Okay, so 3 multiply 10,800, it will give 32,400 voltage. Okay, so the answer is 32,400 volt. Sorry, it's not volt. Okay, this one is turns. Okay, and turns have no unit. NS is equal to the number of turns in the primary coil will be 32,400. Okay, not the voltage, only 32,400. So here option D is correct. So this one was the last MCQ. If you like the video, then share it with your friends. And if you have any problem in these MCQ, then write in the comment section. Allah Hafiz.